This is Trig Identities, part number 27, and I'm going to divide this video into two separate parts. And the reason for that is I have to place a bunch of notes on this particular dry erase board, and I don't want to erase what I already have. So let's start with something simple here, alright? This is a unit circle. That means that the radii of this circle are going to measure one of something. We're going to say in this particular video that this is 1 yard, this is 1 yard, this is 1 yard. Okay? And that's because all three of these angles here, this one here and this one here, are all going to measure 60 degrees. Okay? So this triangle not only is equiangular, but it's also equilateral. Okay? And Ptolemy knew this when he devised his table of chords. As a matter of fact, he formed a hexagon in a unit circle, and he had 6 of these triangles. And each one of these triangles that he had in his hexagon had 60-degree angles on all 3 angles here, and also the measurement of 1. In this case, we're using 1 yard. Okay? Because we all know, well, okay, we can use 1 foot if we want to, because there is 12 inches in a foot. And you could actually use a ruler and a great big piece of paper to draw this. Okay? Now then, what did Ptolemy discover? Well, let's go through this. It really wasn't Ptolemy that pretty much... Ptolemy discovered the table of chords, okay? What he did was he said if you have an angle of 60 degrees, you have a 1 length right here. That's what he said. Right? Now then, several later mathematicians, they came up with this. They bisected this 60-degree angle, just like that. And by bisecting that 60-degree angle here, what they also did was they bisected this side right here. So now we have 1/2 here and 1/2 here. But they also made 2 right-angled triangles. This one here, and this one here. Now the angle size here, the size of this angle right here, did not change, nor did this one here. They're both still 60 degrees. However, because we split this particular 60-degree angle in half, we now have 2 30-degree angles. Like this. That looks about right. Okay. Do you know that the sine of 30 degrees is actually 0.5, which is 1/2? Okay. If you were to turn 1/2 into a decimal, you get 0.5. Well, 0.5 over 1, okay, and you say, well, why are we doing 0.5 over 1? Because if you're trying to calculate the sine of 30 degrees, which that's exactly what we're trying to do, if you do 0.5 divided by 1, you're going to get 0.5. So, the length of this line right here, which is 1/2, also happens to be the sine of the angle 30 degrees. So what? Big deal. Who cares? Okay. What they're saying here, in essence, is because this is a sine right here, and this is a tangent line right here, and we talked about that in a previous video. Okay, we talked about how tangents came to be in the first place. Alright? Remember Book of Shadows, all that other stuff? Okay, fine. Now then, by knowing all of this, alright, so now we can say that the length of this line from here to here is going to be the sine of 30 degrees. Now, why is that important? Why is that important? Well, we're going to get into that in the second part of all this, because you're going to use the Pythagorean theorem you're going to use Ptolemy's table of chords and a few other whopper things, and all of a sudden, you're going to get a trig identity. Matter of fact, you're going to get the tangent identity. Isn't that nice? Alright. I'm going to turn this off for now, and then I'm going to show you the rest of it in just a second. So I want you to stay tuned because this video is not over yet. Let's continue this video. I'm sorry to say that I will have to divide this video into more parts because I had more notes than I realized I did when I first started this video. Okay, so let's focus on this drawing right here. Where did I get it from? Well, do you remember the unit circle I drew a few minutes ago? Okay, and it had that triangle in it. And the triangle was equal angular and it was equilateral, and all the angles in the triangle were 60 degrees, and of course all the sides were 1 foot in length. You remember that? Then you remember I drew that perpendicular that sliced up that one angle from 60 degrees to two 30-degree angles and then made two right angle triangles? Well, that's where I got this from. Okay. Now, do you remember from basic trigonometry when they told you that the tangent of this angle right here was the ratio of the sine of A and the cosine of A? You say, well, I don't remember any of that. Okay, when you're talking about a unit circle, of course, this tangent line is going to be 1. In this case, it's going to be 1 foot because that's what we drew that from the other drawing. Okay? And we already established that this is going to be 1 foot, this is going to be a half a foot, like that. Okay? Now the original tangent formula goes side opposite over side adjacent. Okay? This is a side opposite of angle A. This side here is adjacent to angle A. Okay? And of course, this is the hypotenuse. So, if you have the ratio of the opposite side over the adjacent side, you have the ratio for tangent. In this particular case, the measurement of this side happens to be the sine of A. The measurement of this side happens to be the cosine of A. And how did we get all that? Because tangent right now is 1. That's how we got it. Because 0.5 divided by 1 is still 0.5. And of course, you can figure out the cosine of A if you want to. Go ahead. But anyway, do you remember the law of sines and cosines that I covered in a video way back when? It was a Trig Identities video, but it was way back when. You remember that? And we had the sine of A plus B and the cosine of A plus B. You remember that? Okay. Now we're going to put in some substitution. Now I want you to write this down. I want you to write this equation down because we're going to focus on that in the next part of this video. Alright, you're going to be amazed at what I'm going to show you. Alright, so don't go anywhere. Hang on to your seats because this is going to be a fascinating ride. Stay tuned. Let's continue this video. Boy, there's a lot of stuff right here. You're probably sitting there scratching your head going, what the heck is all of this? Well, do you remember a minute ago when I told you to write this particular equation down? Okay. Now, do you remember the law of sines and the law of cosines? Well, if you'll recall, this and this get substituted. Okay? In other words, there's an equation here that substitutes this. So we're going to replace this with this. We're going to replace this with this. So they're going, oh gee. Alright, well how are we going to solve this gobbledygook right over here? No problem. What we're going to do is we're going to divide by cosine A, cosine B. We're going to divide every single one of these terms by cosine A, cosine B. Okay, every term here is going to be divided. This term is going to be divided. This is sine A cosine B. This is another term, sine B cosine A. This is another term, cosine A cosine B. And this is another term, sine A sine B. Now what can we eliminate? Well, cosine A cosine B divided by cosine A cosine B becomes 1. That's just a 1. Well, that was easy enough. Now, what else can we do? Well, we can divide cosine B by cosine B. So now we can eliminate this. Hold on. Hang on. You're going to love it. It's going to become a lot simpler. All that's going to disappear. So now you have sine A divided by cosine A. And that's all you got. Now then, whoops. That's not correct. I know, you're going to criticize me for that. Sorry about that. So this term is actually sine B cosine A divided by cosine A cosine B. Now I think you can pretty much see what we're going to do here. I'm going to get rid of this. I'm going to get rid of this. So now what you have is sine B divided by cosine B. Alright? So let's just shift this cosine B, just like that. We can do that, no problem. Now what about this? Can we make any changes here? Absolutely not. Alright. So what happens next? Well, what is sine A divided by cosine A? Well, that's actually going to be the tangent of A. What about sine B divided by cosine B? Well, that's opposite or over adjacent, so what are we going to have? What we're going to have is just like that. Okay. Now then, let's make it a little more obvious. Alright. Now then, what about this right here? What are we going to change this to? Okay. Well, what is sine A cosine A? Well, that's going to be T. Well, I don't suppose you'd be able to see that. Let's just wipe this out. Okay. Now, let me make sure I got this right here. Yep. It's going to be the tangent of A, and I'm going to actually smooth this out a little bit more so you can see it. Now, what is sine B cosine B? Well, we'll change this to tan B. Okay, so now we have a fraction that says the tangent of A plus the tangent of B divided by 1 minus tangent of A multiplied by tangent of B. And that is a tangent identity. You can look this up for yourself. But I'm going to elaborate on this particular tangent identity. This is a trig identity. It's a tangent identity. And I'm going to elaborate on this in a future calculus video, because we're going to use this to help us prove a calculus proof. Instead of going, really? We're going to use this equation to help prove a calculus proof? You betcha. And now you know how we got it all. So you can thank Ptolemy and Pythagoras, okay, I'm going to say that again, Ptolemy and Pythagoras, for coming up with this. Alright. And that concludes Trig Identities, Part 27. So like I said, there will be a calculus proof. We're going to be using this, and you're going to see it. Alright. I will tell you more in a future video, so I would like for you to stay tuned.